All right, let's take a look at this proof. Again, I want to go over some proofs that in preparation for the midterm exam. So I want to try and take a look at one of each. This is an example of a proof where we'll actually prove the triangle is congruent and then use CP/CTC, which is basically the definition of congruent triangles, to take it a step further. So in all of these problems, you should always try and formulate where you're trying to go before you actually just start marking things off and using things that you know. Because if you're not headed in the right direction, it might steer you down the wrong path. So in this case, we look at AC bisects angle ABB. As we look at what's given, just realize, like if they tell us something bisects an angle, we're going to use the definition of an angle bisect. They tell us something's a midpoint, we're going to use the definition of midpoint. They tell us maybe some things are perpendicular, we might use that. And then down the road, when we look at some with parallelograms, if they tell us something's a parallelogram or a rectangle or whatever the case may be, we'll use those as reasons. So over here, we know AC bisects angle BAD. And like, again, I should have been like, freeze. Try this on your own before we start. No. I could have just, if you wanted to try this before I go through this, just go back, pause it, try and work out the proof, and then look at us going through the answers. Well, we've got AC bisect angle BAD. I know segment AB is equal to segment AD in terms of their lengths. Again, like I said, there's a side to a side, so put a little S next to that parentheses. Then they tell us something bisects an angle. So like I just mentioned, we're going to use definition of angle bisect. Now what does an angle bisector do? If it bisects angle BAD, so I'm tracing over angle BAD, it divides that whole angle into two equal parts. So that's going to tell me angle BAC is equal to angle DAC. If you wanted to make life easy for you, you could throw some numbers in there just to make naming them a little easier. So angle 1 equals angle 2. Put an A in parentheses next to it. It's like we've exhausted the given. That was nothing to do with that. We used that. Now it's like when we look at a diagram, what are some additional things that we can get out of the diagram other than what's already stated? And after using the given. So that's when we look at things like, is there a reflexive side, a shared side in both triangles? Is there a pair of vertical angles? That's a way to get another angle or another side. In this case, I see that both triangles share the same side, so we can use the reflexive property to say AC equals AC. Put an S in parentheses next to that. And now we should have enough to say the triangles are congruent. If I look at this top triangle, I've got side, the included angle and side, and I've got the same thing in the bottom triangle. A side, the included angle, and a side. So now I can say triangle ABC is congruent to triangle BAC by SAX. Side angle side. Now, is that what we're trying to prove? No, we're trying to prove angle B equals angle D. Now we can take it a step further. Whether it's a proof given congruent triangles or one that you're trying to prove them congruent and take it a step further, after we have a congruent triangle statement, we've always been able to use CP/CTC right after that. It's just an acronym, right? It's basically the definition of congruent triangles. Corresponding parts. What kind of things are parts of a triangle? Sides and angles. So all the corresponding parts of congruent triangles are congruent. Now there's angle B and angle, typo. If I said ABC, then the bottom triangle I had to say ABC. Then you write in a dry erase marker, right? So now, after we look at this, does angle B and angle D correspond with one another? They do. So that's why I can say angle B is equal to angle D because they are corresponding parts. So there's an example of a proof. Prove the triangle is congruent using CP/CTC to take it a step further. All right, let's take a look at this proof. Again, preparation for midterms. We're trying to get through some stuff. If you want, pause the video right now. Try this on your own, and then we'll work our way through it. But I'm going to go ahead and get started on it right now. So here's an example of trying to prove some lines parallel. Again, we can see one of each type of proof that I talked about. Parallel lines. So given parallel lines do something, prove lines parallel. Those are two different types of proofs. Given congruent triangles, prove triangles congruent. Those are two other different types of proofs. And given something's a parallelogram, prove something's a parallelogram. Those are the other two types of proofs. So in this case, I'm trying to prove lines parallel. You got to remember back to all the types of things that give us parallel lines. If we could show a pair of corresponding angles are congruent, I can say the lines are parallel. If I can show I got a pair of alternate interior angles congruent, I can say the lines are parallel. If we can show a pair of same side interior angles are supplementary, that'll give me parallel lines. So again, as we look at this, like, which of those shapes do I see in our figure? Like, that should be the first thing you try to identify. In this case, I see I got a Z going this direction, and I got that Z shape going the other direction. So now, can we either get angle A congruent to angle C, or angle B congruent to angle D? Either one will give us parallel lines. So how are we going to show that? Well, congruent triangles. Pops up again. We start with the given, work our way with that, see where we're headed. So E is the midpoint of segment AC and segment BD. So it comes back to, if they tell me something's a midpoint, you can be assured we're going to use as a reason definition of midpoint. Now what does a midpoint do? A midpoint divides a segment into two equal parts. So if E is the midpoint of segment AC, I know AE is equal to EC. Put an S in parentheses next to it. If E is the midpoint of segment BD, I know that segment BE is equal to segment ED. Put an S in parentheses next to that. After we've exhausted the given, the only other things that we can get out of a diagram is there a shared side? Use the reflexive property. Is there a vertical angle? Well, in this case, I can see I have a pair of vertical angles. So what's true about vertical angles? Well, they are equal. That is a theorem, right? Vertical angles theorem. So I can say angle 1 equals angle 2. Don't write definition of vertical angles. It's not the definition. It's an actual theorem. So you just short it up and say vertical angles congruent. Put an A in there in parentheses. Now, when we think about proving triangles congruent, we had 5 ways, right? SSS, SAS, ASA, AAS, hypotenuse leg, if they're right triangles, right? Or SOS. No, there is no SOS. But now, the reason we're putting those letters is not that order is relevant, but does it match up to one of these? So if I have two sides at an angle, I want to see, is it side, angle, side? Well, notice, two sides, and it's the angle that those two sides make, the included angle. Two sides and the included angle. Now let's get this right. Triangle AEB. Congruent to triangle. Now A is going to correspond with C, E with itself, and D with D. So this is going to be CED. I, S, A, S. That's apostrophe, right? After we get the triangles congruent, I can then say, well, now use CP, CPC. That keeps coming up, right? CP, C, C, C. Corresponding parts, congruent triangles are congruent. Now, what kind of things correspond? Sides and angles. In this case, I want the angle. What's angle A correspond with? Angle C. So I can use CP, CPC to say, hey, angle A is equal to angle C. Now it's like, now I know this, right? And what kind of angles are those? I'll trace over this. Makes that Z shape. There's a pair of alternate interior angles, and we just showed that they're congruent. So now I can say AB is parallel to CD. Alternate interior angles congruent implies parallel lines. Now here's an example of, like, this is what I would call a meaty proof. For those of you that are like vegetarians, we can call it a veggie proof, but this is a meaty proof. It's got a lot of stuff going on in it. It's not just straight prove triangles congruent, but this was congruent triangles, taken it a step further, then proving lines parallel. So here's a good example of working towards proving some lines parallel. All right, let's take a look at this proof now. This is a proof where we're actually trying to prove a quadrilateral is a parallelogram. So you got to remember back to the 5 ways to prove a quadrilateral is a parallelogram. You have to show both pairs of opposite sides parallel, show both pairs of opposite sides congruent, show both pairs of opposite angles congruent, show that the diagonals bisect each other, and then there was, so these were like the flip of what a parallelogram implies. And then there was one special to this, and it was show one pair of sides, either this pair, both congruent and parallel. So if I look at what's given, it's like the fact that I have BC parallel to AD, I've got half of two of them. I've got half of showing both pairs of opposite sides parallel. So if I could show these parallel, I could call it a parallelogram. And I got half of the one showing one pair of opposite sides congruent and parallel. Now, how are we going to get the rest of it? So if I want to get the rest of it in here, I've got some parallel lines, which means I've got that Z shape going this way, alternate interior. I got the Z shape going this way, alternate interior. That's going to give me some angles. I got M as a midpoint of a segment. That's going to give me a segment. And we're going to see, hey, maybe I can prove some triangles congruent based on that fact. Well, we should notice that the Z in both cases gave me these angles and these angles. So it makes sense to look at those two triangles right here, prove these two triangles congruent, and then we can use, again, our good old friend CPCP2. And just clear that up. So take your pick. What do you want to go with first? Parallel lines imply something, or definition of midpoint? Not one way is more correct than the other, but let's go with the top. We can say parallel lines imply alternate interior angles congruent. Now again, if we've got, actually, is that a glare on the board? I've got a shade down here. Let me go. Pull the curtain down. Ignore the man behind the curtain. There we go. That's better. Oh, that's snow outside. Got a fierce glare on you, but parallel lines can be alternate. So if I don't have numbers in the diagram, I can throw some up there just to make life easier for me. So angle 1 and angle 2 are alternate interior angles. Angle 3 and angle 4 are a pair of alternate interior angles. Now I've got two angles in one triangle congruent to two angles of another. If you didn't use both pairs, you could have used the vertical. It doesn't matter. It's just going to change how you would prove the triangles congruent. But if I check, I used everything with a parallel line. Tell me something's a midpoint. What are we using as a reason? Definition of midpoint. Midpoint gives me two equal segments, right? M is the midpoint of segment BD, so it divides that segment into two congruent parts. Segment BM equals segment MD. There's a side, right? Now, don't look at that. Don't be like, oh, it's angle, side. You're going to look at the diagram to make sure what it is. Because if it's angle, side, or angle, side, angle, they're two different things. Notice, angle, side. It's not the included side, the side between the two angles. And that's the same thing down here, angle, side. So now we can say the triangles are congruent by AS. That's going to give me triangle BMC. Congruent to triangle. Now B corresponds with D, N with itself, and A with C. Now I'm going to elect to pick getting these triangles congruent by one pair of opposite sides congruent and parallel, because that seems the easiest right now. Because now that I have the triangles congruent, notice BC and DA correspond with one another. So when I use CBCDC, I can say, hey, segment BC is equal to segment DA. And now I've got one pair of opposite sides that are both congruent and parallel. Now we can say ABCD is a parallelogram. One pair, opposite sides, congruent and parallel. Again, there's like a meaty proof, a lot going on there. Proving some triangles congruent, CBCDC, to then get something as a parallelogram. That's basically it. So again, my recommendations for the exam: go through your exam review packets, work through any of those problems aside. Don't wait till the night before. If you do that, you're basically setting yourself up for failure, right? So you got a couple days, you got a weekend, whether your exam is Monday, Tuesday, Wednesday, or Thursday of next week. to take some time reviewing and going over this stuff between now and then. And good luck. I'll be available for after school. And you guys want to come in, some of you guys will have an exam review period the day before. You have ample time to ask some more questions. But good luck with this, and hope all this stuff helps you guys.